Hello students, today we are going to study about the elements of the periodic table. You know, in our previous video we came up until the model of the atom. By now I hope you all know where the proton is, where the neutron and where the electron is present. So therefore today we are going to talk about each and every element. How many protons does it consist, how many neutrons does it consist, how many electrons does it consist, and how is the arrangement of the electron. And we are going to talk about the characteristics of the periodic table. Yes, to start off, a small summary of the previous lesson. I hope you all can remember that an atom, we draw the core of the atom, nucleus of the atom, first energy level, second energy level, third energy level and the fourth energy level. Inside the nucleus of the atom we have protons and neutrons. On the energy levels we have the electrons, distributed electrons. We know that the maximum electron which is held by the first energy level is 2. Maximum held by the second energy level is 8. Maximum held by the third energy level is 18 and maximum electrons held by the fourth energy level is 32. This is according to the international standard. But according to the local O levels, we have to speak about the first 20 elements of the periodic table. Therefore, we will not need this. So therefore, we are going to talk about the first energy level, 2 electrons. Second energy level, 8 electrons. Third energy level also 8 electrons. Fourth energy level also 8 electrons. For us, this is enough to complete the chapter today. Yes, the next one is, we know that protons is present inside the nucleus. You all have to clearly understand that the proton is the subatomic particle which determines the name of the atom, because modern scientists have told that proton is the atomic number. If proton is the atomic number, it is the one which gives the name. For example, if any atom has only one proton, we call it hydrogen. 2 protons, we call it helium. 3 protons, we call it lithium. 4 beryllium. And likewise 20 proton, it is called as calcium. So remember that proton is the unique subatomic particle by which the name of the element is derived. Proton number is equal to atomic number. Therefore, 1 proton is equal to 1 atomic number. 2 proton, 2 atomic number. Then the next one is the neutron. Neutron is also present inside the nucleus, but the neutron doesn't have a specific order. Now, if you consider this order, hydrogen, helium, lithium, beryllium, we know that hydrogen has 1 proton, helium 2 proton, lithium 3 proton, beryllium 4 proton, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9. So if we want to fill this column, the proton column, so you have a look at this column. We have the element, then the proton number, neutron number, mass number and the electron number. So I hope we can fill the proton number with this. Proton number of hydrogen is 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9 and neon is 10. Likewise, you can fill all the 20 elements. That is about proton. Then when we talk about neutron, it is present inside the nucleus, and neutron value is also given. But the thing is, neutron doesn't have a pattern like this. Therefore, Either you have to memorize the neutron number or they will give the neutron number. Normally if they give any question related to this, they will give the neutron number or they will give the mass number. From that you will be able to find the neutron number. So in case if they give the neutron number, we can write it here. So later we will be writing everything. So neutron also done. These two are present inside the nucleus. We know that proton and neutron are present inside the nucleus. Because of the proton and the neutron, the whole atom gets a weight or a mass. We call it the mass number. Actually, to say, the real mass of an atom is very small. It is sometimes 10 to the power minus 23 or 24. So it is very small. Even the machine which calculates the smallest particle is not enough to calculate the weight of the atom. But by using some calculation methods, we can derive the weight of an atom. If we consider the weight or the mass of an atom, it is very small. So we cannot do calculations with it. So if you take the mass of the atom, it is very small. So you can't represent it in our normal day-to-day activities or in our calculations. Therefore, scientists have come up with a small theory. The theory is, if proton number is 1, for example neutron number is 1, then the mass number or the mass of the atom is considered as 2. Mass number is equal to proton number plus neutron number. Proton number plus neutron number gives the mass number. So for example, if I tell you that hydrogen atom has only one proton and it does not have a neutron, so neutron is 0. Now tell me, what is the mass of the hydrogen atom, mass number? Yes, it is 1. Now you all can come up with a question. Yes, we have spoken about proton and neutron. Then what about electrons? Don't electron contribute to the mass of the atom? No. Actually, if you consider proton, actually the weight of the proton is 10 to the power minus something. Minus 23, minus 24, something like that. But for our easy calculation, if we consider proton, mass of the proton as 1, mass of the neutron as 1, then the mass of the electron will be 1840 times smaller than them. So already this one's weight is very small. 1840 times smaller than this is a very small amount. Therefore, we don't consider weight or the mass of the electron when considering the mass of the atom. Therefore, electron's weight is very negligible. For example, we can say, if the proton and neutron is like a football, if there is 1 or 2 ants running around the football, will we consider the weight or the mass of the ant? We will not consider. Someone kicks a football and says the football didn't go up because there were 2 or 3 ants in it. Will we take it? No. Because ant staying on a football, the weight will not change. It is very negligible. Same like that, if an electron is present in the atom, the weight of the electron is negligible. Therefore, we don't consider the mass of the electron when calculating the mass number. Therefore, don't need to worry, only the proton number and neutron number forms the mass number. So, either they should give the neutron number, then we can find the mass number, or else they have to give the mass number, then we can find the neutron number. So, I will give some mass numbers and some neutron numbers. We'll try to find the. Now we will be writing few neutron numbers. So they have to either give the neutron number or the mass number. So we'll write few neutron numbers. The neutron number of hydrogen. Hydrogen doesn't have a neutron. Therefore it is 0. Neutron number of helium. It is 2. Neutron number of lithium. It is 4. Neutron number of beryllium is also 4. Neutron number of boron is 6. Neutron number of carbon is also 6. Neutron number of nitrogen is 7. Of oxygen it is 8. Of fluorine it is 10. And of neon it is 10. Therefore, you can see that there is no pattern in this 0, 2, 4, 4, 6, 6, 7, 8, 10 and 10. So there is no pattern, they will give it. If they give the neutron number, you will be able to find the mass number. So 1 plus 0 is 1, 2 plus 2 is 4, 3 plus 4 is 7, 4 plus 4 is 8, 5 plus 6 is 11, 6 plus 6 is 12, 14 plus 14, 7 plus 7 is 14, 8 plus 8 is 16, 10 plus 9 is 19, 10 plus 10 is 20. Therefore, you can see that if the neutron number is given, we can find the mass number. Or else, if the mass number is given, you can find the neutron number. The next 20, we will do it like that. The mass number of sodium is 23. The mass number of magnesium is 24. Mass number of aluminium is 27. Mass number of silicon is 28. Mass number of phosphorus is 31. Mass number of sulfur is 32. Mass number of chlorine is 35. Mass number of argon is 40. Mass number of potassium is 39 and mass number of calcium is 40. So mass number also there is no pattern because neutron number also doesn't have a pattern. So we'll calculate the neutron number. What is the neutron number of sodium? Proton number 11, mass number 23. 23 minus 11, it is 20, it is 12. 24 minus 12, it is also 12. 27 minus 13, it is 14. 28 minus 14, that is also 14. 31 minus 15, it is 16. Therefore, neutron number of phosphorus is 16. 32 minus 16, that is also 16. So sulfur 16. Chlorine 35 minus 17 is 18. 40 minus 18 is 22. 39 minus 19 is 20. 40 minus 20 is also 20. Now we will look at the electron number. Electron number, now don't think there is neutron number and mass number, again the electron number. Electron number is very easy. Electron number is initially similar to the proton number. So very easy, it comes according to the pattern. So electron number of hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, then sulfur 16, chlorine 17, argon 18, potassium 19, and finally calcium is 20. So it is very simple. So we can say proton number, atomic number and the initial electron number are all the same. So we have completed half of the chart. Now the next thing is called the electronic configuration. What is the electronic configuration? It is the pattern in which these electrons are arranged in an atom. We know that there are energy levels or shells. First shell, second shell, third shell, fourth shell. We have a pattern of arrangement of the electrons. maximum first energy level 2 electrons, maximum second energy level 8 electrons, then again 8, then 8. So we'll consider this and try to fill this column. In this column we have 4 parts. First part is the first energy level, that is the K level. Second is second energy level, L level. Third one is third energy level, M. Fourth column is fourth energy level, that is N. So hydrogen, it has only one electron, therefore that one electron will be present in the first energy level, so 1. Helium, 2 electrons, both the electrons will be present in the first energy level, so we write 2 here. What about lithium? Lithium has 3 electrons, first 2 will be in the first energy level and the remaining one will be in the second energy level, so 2, 1. 2, 1 is the electronic configuration of lithium. Beryllium, it is 4. The electronic configuration will be 2 and 2. What about the electronic configuration of boron? 2 and 3. Carbon, 2, 4. Nitrogen, 2, 5. Oxygen, 2, 6. Fluorine, 2, 7. Neon, 2, 8. Sodium, 2, not 9, 2, 8. 8 is the maximum number of electrons in the second energy level, so we'll go to the other one. The remaining will fall to the other one. 2, 8, 1. Magnesium, yeah, 2, 8, 2. Then 2, 8, 3. 2, 8, 4. 2, 8, 5. 2, 8, 6. 2, 8, 7. 2, 8, 8. 2, 8, not 9, 8, 1. And the final one, 2, 8, 8, 2. We have only 20 elements in the periodic table that we should study, so our maximum electronic configuration will be this. So if we follow this 2, 8, 8, 8 theory, we will be safe until we finish our ordinary level. Yes, the final part for the elements, that is, we know that maximum electrons held by the first energy level is 2. If an element has that configuration, it is considered to be stable. Or else, second energy level is 8. So if an element has 2, 8, it is stable. Or else, the third one, it has to have 8. If it has complete electrons in energy levels, then it is stable. So out of this graph, first energy level, maximum 2 helium is having. Therefore, helium is stable. That means hydrogen is not stable. When we consider lithium, not stable. Beryllium, 2 and 2, therefore not stable. Boron, 2 and 3, not stable. Carbon, not stable. Nitrogen, not stable. Oxygen, not stable. Fluorine, not stable. Then what about neon? 2 and 8. 2 maximum and the second energy level maximum is 8. So both are complete. It is stable. Then the next one. Sodium, not stable. Magnesium, not stable. Aluminium, not stable. Silicon, not stable. Phosphorus, not stable. Sulfur, not stable. Chlorine, not stable. And then we have argon. Argon has 2, 8 and 8. It is stable. Then potassium and calcium are not stable. So from our periodic table, out of the 20, only 3 elements are stable. Helium, neon and argon are stable. All the others are unstable. Later in the upcoming chapters you will understand unstable elements form bonds by giving electrons or taking electrons or sharing electrons to become stable. They give electrons, take electrons or share electrons to become stable, because they cannot be unstable every time. They have to become stable. To become stable, they have to reduce or increase their electron number. So later we will be speaking about it under bonding chapter, about how the bonds are formed. So for now we know that 3 elements are stable. This is the full detailed theory of the periodic table. Please take this down. I want everyone to have this chart completed in their writing book, or if someone has the tute, the chart is given, fill the tute with the given values. Now we look at the standard way of representing an element. It is the standard way. For example, if we consider X as the element, it can be any element out of this. We have A. A is the mass number of the element. And we have Z. Z is the atomic number. If we are summarizing it, A is the mass number, Z is the proton number or the atomic number. So the standard way of representing an element is this: A, X and Z. So we'll consider some element. Yes, we'll consider helium. How are we going to represent helium in a standard method? X is the symbol of the element. What is the symbol of helium? He. So He, and the mass number of helium is 4 and proton number is 2. This is the standard way of showing helium atom. Let's take sodium. Sodium. What is the symbol of sodium? Na. What is the mass number? 23. And what is the proton number? 11. Na, 23 and 11. This is the standard way of representing sodium atom. So I hope you all have understood the standard way of representing an element. For us, this is a very easy task, because already all the elements and the mass number, proton number, neutron number has been already found. But at the initial period, one scientist from one country found out about this, then some other scientist found out about this. So it was a collection of a lot of data. So after putting all the data together, one single individual couldn't keep everything in memory. Now this 20 is okay, but all the 120 or 119 elements, so one person can't keep everything, all the pattern and all the characteristics in him. So they wanted to bring about a pattern in the periodic table. So the scientist called Dmitri Mendeleev, he found out that there is a recurring factor, a recurring pattern in the periodic table. So according to the recurring pattern, when he considered this from helium to fluorine, there was a pattern in them, and some characteristics were increasing, some were decreasing. Then again after neon, sodium, again that character started increasing or decreasing. So we will look at the characters later. Because of this pattern present inside this, he made a short chart. That is what we call as the modern periodic table. So Dmitri Mendeleev came up with the modern periodic table. So the modern periodic table, as we know, I hope you all have seen the video about the modern periodic table, the short clip about how to learn the periodic table. So with that, we'll draw it quickly. So we have hydrogen, then we have helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then again sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium, and finally we can put helium here. So we had many short forms: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Yes, you can learn it in this method or the short method. To learn about the short method, check the previous videos. So we get the modern periodic table. This was brought out by the scientist called Dmitri Mendeleev. According to him, these columns were considered as groups. So he named it in Roman number: group 1, group 2, group 3, group 4, group 5, group 6, group 7 and finally group 8. This group 8 is also considered as group 0. We'll see why. This is the group number. Then every row, first row, second row, third row, fourth row, was considered as period. First period, second period, third period, fourth period. Don't get confused, it is very simple. Like the school timetable: first period, second period, third period, fourth period, then you have interval or the play time, then fifth, sixth, seventh. So like that, first row, first period, second row, second period, third row, third period, fourth row, fourth period. First group, second group, third group, fourth group, fifth group, sixth group, seventh group and the final eighth group, or it is also called as the zero group. Now we are going to consider how we divide these elements according to groups and period. How did this arrangement come? So group, first we'll look at groups. Group 1, group 2, group 3. This category was derived by the number of electrons in the last energy level. The number of electrons in the last energy level. So sometimes we can call it as valency number. The number of electrons in the last energy level, or the valence number. So for example, hydrogen has 1 electron, so it has come to the first group. Lithium, 1 electron, therefore first group. Sodium, again 1 electron, first group. Potassium, 1 electron, therefore it is in the first group. Then we will consider any element. Now see nitrogen, 2, 5. 5 is the number of electrons in the last energy level. So depending on the number of electrons in the last energy level, it falls in the fifth group. So group is decided by the number of electrons in the last energy level. The last energy level is called as valence shell. The other name for the last energy level is called the valence shell. So you can say the number of electrons in the valence shell decides the group. Or in other words, number of electrons in the last energy level decides the group. Okay, then what about the period? Period is decided by the number of shells or the number of energy levels. For example, if you take hydrogen, it has only 1 energy level, only 1 shell. Therefore, 1 energy level, first period. So lithium should have 2 energy levels, so it will fall in the second period. So lithium, 2 and 1, K and L, occupies K and L, 2 energy level, second group, second period. Beryllium, 2 and 2, occupies 2 energy levels, so second period. 2 and 3, occupies 2 energy levels, therefore second period. So all these elements fall in the second period. And from here, from sodium onwards, 1, 2, 3, it occupies 3 energy levels. So sodium falls on the third period. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Here 3 occupies 3 energy levels. Here 3, again 3, and until argon it occupies 3 energy levels. The final 2 elements occupy 4 energy levels. 2881, 2882. It occupies all 4 energy levels. Therefore, it falls in the fourth group. This is how the group number and the period number came into existence. Now we are going to talk about the periodic table. I hope you all by now you all have memorized the periodic table. So there are a lot of patterns present in the periodic table. For example, size of the element. There is a pattern. First, ionization energy, electronegativity. All these three will be uploaded in our next video. For now, we are going to consider about the property. Some of the elements in the periodic table are metal, some are non-metals, some are gases, some are solids. So we are going to talk about those things, the physical nature of the elements present in the periodic table. So to start off, we'll consider about the periodic table. Normally, to the left of the periodic table, this is my left hand, to the left of the periodic table, we consider that it has more metallic nature. Left side metallic nature, right side non-metallic nature. Non-metals, metals. Then in between there are few elements which have metallic characteristics as well as non-metallic characteristics. Therefore, we cannot properly divide them into metals or non-metals. These type of elements are called metalloids. These type of elements are called metalloids. That means in our periodic table we have metals, non-metals and metalloids. So all these three arise from the periodic table. How many elements are present in the periodic table? Tell me. Yes, 20 elements. So these 20 elements are divided according to metals, non-metals and metalloids. I told you towards the left side of the periodic table it is metals, towards the right side it is non-metal. In the middle there are few metalloids. So first we'll speak about the metalloids. There are two metalloids in our syllabus. So very easy to remember. Just remember these metalloids are very bossy. You know people who are bossy, they always tell you do that, do this. So these metalloids are bossy people. Who are the two bossy peoples in our periodic table? Boron and silicon. Bo-C. So boron and silicon fall under metalloid category. Boron and silicon. So we have two metalloids. All the others fall under metals or non-metals. So the users of these non-metalloids will be learning it later. So then we'll check the metals. So I told you already the left side ones are metals. That means the elements which are towards the left of boron and silicon are metal, and the elements which are to the right of boron and silicon are non-metal. So very easy. But there is an exception. Except hydrogen, all the other elements are metals. Because hydrogen is a non-metal, it is a gas, later we will be studying. It is a non-metal, it has to come to that side. But because its proton number is 1, electron number is 1, we put it here just to adjust the periodic table, or else it should fall in the non-metal side. Okay, so who are the metals? Metals in red. Lithium, beryllium, sodium, magnesium, aluminium, potassium and calcium. So we have 1, 2, 3, 4, 5, 6, 7 metals. So we have 7 metals. What are they? Lithium, beryllium, sodium, magnesium, aluminium, potassium and calcium. So these are the metals. Then next we'll consider about the non-metals. Then who are the non-metals? All the remaining ones: hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon. All those are non-metals. Before going to their classification, when we consider these metals, all the metals in our periodic table are actually solids. All these are falling under solids. We know that there are three states of matter. In the starting of the chemistry chapter, we saw solids, liquids and gases. When you consider these 20 elements, all the metals in the 20 elements are solid. When you take the overall periodic table, 119 to 120 periodic table, all the metals are solid. We know that metal has to be solid, but there are few exceptions. For example, mercury is a metal, but it is liquid at room temperature. When you cool it, it becomes solid, but at room temperature, at our normal room temperature, mercury is liquid. You can pour mercury into a glass, but it is a metal. It has characteristics of a metal. So all the elements in the 20 element periodic table, all the metals are solids. So no need to worry about that. When we consider metalloids, all of them, they are also solids. But when we consider the non-metals, some are solids and some are gases. So the non-metals we can divide into two groups depending on their state of matter. So first we'll look at the solid non-metals, then we'll look at the gaseous non-metals. We don't have liquid non-metals in the 20 elements. So when you look at the solids, yes, in black, non-metals which are solid, there are 3 non-metals which are solid. So totally how many non-metals? Metals 7, metalloids 2, 7 plus 2 9, 9 minus 20 11. That means there are 11 non-metals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where is the next one? With hydrogen 11. So 11 non-metals. Out of that 11 non-metals, 3 are solid. Then how many gases? 3 minus 11, yes, 8 gases. So we'll consider about the solids. Who are the solid non-metal elements? Carbon, phosphorus and sulfur. Carbon, phosphorus and sulfur are the solid non-metals. Then when we consider about the gases, there are 2 categories, 2 types of gases. So we call one type of gas is called as noble gas. Noble gas. Noble gases are the elements which can form gas without bonding to another atom or without bonding to any of the atoms. For example, we studied that helium, neon and argon are considered as stable elements. They do not form bonds with anyone, but their nature is gaseous. They alone, helium alone can form a gas. Neon alone can form a gas. Argon alone, one atom of argon is a gas. So it does not need to bond with another one to form a gas. Therefore, 3 out of the 8 gases are noble gases. So who are they? Helium, neon and argon. It can be called as noble gas or inert gas. Inert means they do not react with anyone. Then the next one, out of 8, 3 gone, then 5 remaining. So helium, we color helium, neon and argon. Then 1, 2, 3, 4, 5 non-metal gases remaining. They join with each other. For example, hydrogen joins with another hydrogen to form a gas. One hydrogen alone cannot form a gas. So I call them normal gas. Noble gas and normal gas, but this is not a standard name because this is noble gas, this is a normal gas. Who are the normal gases? Hydrogen, but one hydrogen alone cannot form a gas, therefore H2. Nitrogen, one nitrogen alone cannot form a gas, therefore N2. Two nitrogen forms a gas. Then we have oxygen, O2. Then we have fluorine, F2, and chlorine, Cl2. Hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas. So 5 elements. So hydrogen, nitrogen, oxygen, fluorine and chlorine. So this is the total periodic table divided according to their metal, non-metal and metalloid nature. So we have metals, non-metals and metalloids. So very easy to remember, two metalloids, remember them, and the metals. To the left of the metalloids it is metals, to the right of the metalloids it is non-metals. So I would like to give a homework to my class students. I want you all to write the metallic and non-metal properties. So this is a very easy one. From grade 7 onwards, grade 7 and in grade 9 and now in grade 10, you have to write a small chart. Properties of metal, properties of non-metal. Properties of metals and properties of non-metal. For example, I'll just give 2 or 3 properties. Metals conduct electricity. Non-metals do not conduct electricity. Metals, they are sonorous. What is sonorous? When two metals are struck, it gives a ringing sound. Non-sonorous. So likewise, I want you all to write all the properties of metals and non-metals and submit it. I hope now you all are clear about the total periodic table and its features, physical properties. The next video will be regarding the first ionization energy, electronegativity and the size of the elements. So I hope you all are following our channel by now. Please go through the videos carefully and take down all the needed notes. And also please share this video with your school friends and with your family members, because it will be very useful at this period of time for everyone to study at home. So you can like the video and subscribe to the channel and share it with your friends. Thank you.